Good morning, guys. So far, we learned the definition of the area moment of inertia and its equation in integral form, as well as the equations of some regular shapes like the rectangular shape, the circular shape, and the triangular shape. So basically, guys, we proved this equation, which is Ix is equal to bh cubed over 12, and this is the area moment of inertia for a rectangular shape around x-axis. This x-axis is passing through C. What is C? C is the centroid of this rectangular shape. Now what if I need to find the moment of inertia of this rectangular shape about an axis x prime parallel to this x, but it is not passing through the centroid C. So for example, I need to find the moment of inertia of this rectangular shape around the space here. What should I do? I know that Ix, which is the moment of inertia around the x-axis passing through the centroid, is bh cubed over 12. But how to find the moment of inertia about another x prime or about another y prime for different shape, rectangular shape, circular shape, triangular shape, or even for irregular shape? This is basically by applying the parallel theory. So what is the parallel theory? The parallel axis theory for any area, is it regular or irregular, states that Ix is always equal to Ix prime plus this area A times the distance, the perpendicular distance between x and x prime. And I know, guys, that in 2D the perpendicular distance between x and x prime is in y. So that's why I can say that Ix is equal to Ix prime plus AD squared y. Now what is x and x prime here? Basically here x prime is the known axis passing through the centroid C. So all the moment of inertia that we found for regular shapes are around the axis passing through their centroid, which is here illustrated by x prime. If I need to find I around another axis x parallel to this x prime, but it is not passing through C, I should apply this theory. So this theory states that I around this axis is equal to Ix prime given by the rules of the regular shape plus the area that I am finding its moment of inertia times the distance in y direction between this x and this x prime. So that's it, guys. This is dy. If I need to do now Iy, it is the same, except that now instead of dy, I have dx, because dx is the perpendicular distance between y and y prime. This is dx. So that's it, guys. If I know the moment of inertia around an axis passing through the centroid C and I need to find the moment of inertia around another axis, what should I do? I should apply the parallel theory. Now, guys, what if I have a shape composed of some regular shapes like rectangular shape and square with a hole with a triangular shape, and I need to find its moment of inertia? The question could be, guys, to find its centroid and its moment of inertia around the axis passing through the centroid of the whole shape, because I should indicate what is the axis that I need to find the moment of inertia around. So for example, guys, I have a shape composed of different regular shapes, and I need to find its moment of inertia around the x-axis passing through its centroid. What do you think are the steps? Of course, guys, first I should find the centroid. I should first find the centroid of the whole shape, and this is basically by applying the method of area that I have explained in the first video of this chapter. So first, find the centroid. Second, draw the axis X or Y that I need to find the moment of inertia about. And then, guys, third, find the moment of inertia for each regular shape around their centroid. Fourth, find the distance, the perpendicular distance between each centroid and this axis that I need to find the whole moment of inertia around. And fifth, apply the parallel axis theory. So these are the steps. I know that it's not obvious now until we solve the first problem, and let's do it.
Okay, so guys, in order to understand how to apply the steps to find the moment of inertia around a certain axis, let's take this example. I have here a beam in L, alright, and I need to find, this is the question, it is to find the moment of inertia around X and the moment of inertia around Y of what? Of the centroid of the whole beam. Which means, guys, I need first to find this centroid. I need to find the centroid, this is the first step, and the second step is to draw X passing through the centroid and Y passing through this centroid in order to find Ix and Iy. So let's guys start by applying the first step, which is to find the centroid. First of all, guys, in order to find the centroid, you should divide this beam into two regular shapes, because I know the centroid for regular shapes. So guys, here as you can see, I have a beam in L. So what I want to do, I will divide this beam into two rectangular beams. So I will take this as my first beam. So this will be 1. And this as my second beam, and this will be 2. Alright? And then guys, since I divided from here, I should know this dimension. So if the given is from this point to the ending point, it is equal to 9. So you should find this dimension here, which is 9 minus 1, which is 8. And this will be 1, of course. And then guys, I can apply or I can find the centroid by finding the centroid of each shape and then do the rule of the method of Taylor, okay, as you can see in the previous video. So guys, let's start by the first shape. So in the method of Taylor, this is how I can do it. I divide my shape into regular shapes, find their area, xy of their centroid, find xa, ya, and then find x of the centroid, which is the whole centroid, as sum of xa over sum of a and sum of ya over sum of a. Now guys, in the first shape, this is the first shape, it is a rectangular shape. The centroid is located at this point right here. So this should be 2, y will be 2, and then x will be 0.5. Now, if you don't have x and y, you should define them, you should indicate them, and in order to prevent any negative y, you can, or any negative x, you can take them at the first point of the speed, which is here. Alright, so this is the origin now, so this is y and this is x, and now all my coordinates are positive. And even guys, if you take it here, for example, at the midpoint, what you should pay attention to is that here y will be negative. Alright? So to prevent all of this, I will take my origin here. So this is all. Now guys, the area of the first shape is 4 times 1, which is 4. Its x is 0.5, its y is plus 2, then xa will be 2, ya will be also 2. In the second shape, guys, which is this one, the area is 8 times 1 inches, and x will be equal to, so this is x, I have 1 here, don't forget, I have 1 here, and then I have 4 here, which means it is 5, and y, guys, is equal to 0.5, then XA will be equal to 40, YA will be equal to 4, then the sum of area will be equal to 12, the sum of XA will be equal to 42, and the sum of YA will be equal to 6. YA is 8, it is not 2, alright? So the sum of YA is equal to 12, and then guys I can find X of C, which is sum of XA over sum of A, 42 over 12, and this will be equal to 3.5. Y of C, which is sum of YA over sum of A, which is 12 over 12, and this will be 1. So this is how I can apply the first step. Now the second step is to indicate the axis that you need to find the moment of inertia along. Now here guys, since basically I need to find Ix and Iy, so I should start by the first axis here, which is X. Alright, so I will do X and then I will tell you what should be the modification to do Iy. Guys, after doing this and finding the centroid, I will draw the x-axis that I need to find the moment of inertia along. Let's first draw C. Alright, so C will be at 3.5. So basically, guys, this is 1 and I have 4 here. So basically, C will be a point, let's say, here. And Y of C is 1, which means, guys, that basically C will be on this line. So this is C. Okay, because this is equal to 1. Alright? And then, guys, I will, in order to find Ix, which is basically lying, so this is Ix passing through C. So this is, let's say, X prime. And I need to find the moment of inertia around this X here. Alright? Or passing through C. So find Ix and Iy where X and Y are passing through C. Alright, so pay attention, guys. This Ix is about the axis passing through C, which means it is about X prime parallel to X passing through C. And in order to do this, guys, I should also apply the method of table for the centroid. It will give me directly I by doing the sum of Ix, alright? So how to do this, guys? It is the same as the centroid for the first two columns. So first I should indicate the shape. What is the shape? And then, guys, I should indicate the area of the shapes. Then I should find Ix around what? Around the centroid of this shape, alright? So around the centroid Ci, let's say, alright? And then since I should find Ix, remember in the explanation, since I should find Ix, so I should find dy. And what is dy? Dy, guys, is the perpendicular distance between x and x prime. Alright? So this is dy, of course. And then, guys, I can find dy squared times ay in order to apply the parallel theory to find I around this x prime, which is Ix, which is the question basically. And this is Ix around Ci, the centroid of the shape, plus dy squared times A. So that's it, guys. This is the parallel theory, and then I can apply this table, find the sum of these two Ix prime, and this will be my